Marten, thank you very much for joining us here on AU Manufacturing Conversations. Good to have you on the program.
Pleased to be here, Brent. Great to speak again.
So the first question, as it always is how did you get here and what do you make?
So we're from Additive Assurance, and we make quality assurance solutions for metal 3D printers, particularly laser powder bed fusion printers. So this is quite a long backstory, as any startup typically is. Mm-hmm. But it originally came out of Monash University, where we were researching originally fatigue of metal additive manufactured parts. And some of the main ways in which metal additive manufacturing parts fail in fatigue is less about the microstructure and more about the macrostructure, or points of failure that are built in using the manufacturing steps themselves. So that's where we started from. And along the way, we had some issues with a particular printer. We had issues with laser stability and things like that. And to cut a long story short, we ended up researching ways to identify when faults were occurring on that machine. So when we did that, we started taking it to the next level and started digging into the data that we were getting out of it using this new sensor that we put together in the lab. And we realized that we could spot the formation of different defects and very small defects using this technology. So when that happened, we, of course, got very excited and, started talking to the industry about what this could mean. It turns out there was a lot of people that were very interested and very keen to solve this problem of quality control. So the rest, as they say, is history. But, all started out of a tinkering in the lab, effectively, and grew from there.
I remember last time we spoke, you mentioned that you were at, I think, a Woodside Energy Lab, is that the name of it? And you were installing a concept laser printer of some kind, and the issue you were having completely confounded the IT help at the other end. Is that more or less the case?
Yeah, not to say anything bad about concept laser necessarily, but it could happen to anyone. We had a machine that I was looking after in the new Woodside Innovation Centre, as it was at the time, and had some significant faults. Yeah, I was looking into why those faults were occurring, and one of the difficult things if you're buying a machine from, in this case, Germany, from the other side of the world, is trying to convince them to send a technician out to the other side of the world to come and fix it when a problem occurs. So, yeah, we had to gather very extensive information about the faults of the machine to be able to convince them to come out. So eventually I fixed that machine. So that was all's well that ends well. But what really came from that was the discovery of this melt pool imaging technique that we've used and been able to establish as a quality measurement method for metal additive manufacturing.
Right, so I'd like to hear a little bit more about melt pool imaging and how Amorous works. Could you tell me how that happens and if the complicated geometries that additive manufacturing designers seem so in love with are any sort of obstacle to what you're doing?
Yeah, no, so with additive manufacturing, of course, the benefit is that you can place material more or less wherever you need to create a fairly optimal design. Of course, there are some caveats and restrictions, as there are with any manufacturing technique, but the freedom and the flexibility is quite captivating. With our methodology, we're really filling that gap. So using 3D printing, placing material wherever you want it, there can be some differences in the thermal pathways and in the consolidation of that material and interaction with the laser and the material itself, leading to defect formations that are very much undesirable. So being able to inspect them all at the same time is really what we offer and what we've been able to do, and the entire reason why we exist. And so it's been really great to be able to offer that to a service to a broad range of different manufacturers around the world.
Nice. And your existence has been validated a little further this week with the news of your raise, which is why we're talking. Is it a Series A the release didn't mention, or is it a post-seed, or what's the sort of status of it?
In this day and age, you can call fundraising rounds what you want. I think those terms really don't mean very much these days.
They're sort of decorative, right?
Needless to say, this is our third funding round now. Then we've also had some grants along the way. So, call it what you want, I guess.
Okay. Of course, I'd like to know what this round, whatever you want to call it, is going to enable. What are you going to take on board in terms of extra technical and business development expertise? And what on earth is a additive manufacturing quality assurance center of excellence as you're looking to set up?
Yeah, we've got some big plans coming up in the next little while, next year or two. Yeah, predominantly we've found that this technology in the space that we're working in is quite global. So coming from Australia is fantastic to have, a strong access to talent and the great resources and support that we have here. But fundamentally, as a manufacturing company, to have scale, you need to be able to reach those major overseas markets and have a presence there. So we need to set up those functions in some of those countries, sales and support and those kinds of things. So that's part of it. But the other part of it is, that center of excellence that you mentioned there, Brent. So we're creating a demonstration facility that will allow operators to come in and experience our technology and experience the benefits of additive manufacturing. But at the same time as well, allow us to continue to evolve our product offerings and serve as a test bed for enhancing the quality of 3D printed parts.
And so I'd like to know a little bit about what people are saying about deep tech startups, because they have gotten quite a bit of attention in the last few years. And you hear that with the economy slowing down, people are more reluctant to invest in something that might be perceived as risky because, of course, deep tech, call it that if you want, is a hard thing, generally speaking, to do. What have you noticed from people considering investment? Has it become a little harder? Has there been a little more justification involved to put your case to investors?
The industry is always evolving and different. I think there's always, when it comes to deep tech, there's always a hot button topic of the minute, and that continuously changes. If you look back 12 or 24 months, crypto and crypto-related technologies and other new finance-related things were the flavour of the moment and attracted a significant amount of funding. But now that's obviously gone quite the opposite direction with recent developments in particular. But then, that's obviously continuing to evolve, and there's always these hot-button topics. I think the thing that's really important to mention, no matter what the flavour of the day is for companies that are doing good work and building real products with real clients, there's always a market for that, and there's always funding available for those businesses. It may be difficult to, get an introduction to some of these venture groups if you're not tackling one of those hot button topics of the day, but it's still, with good work, producing good products, that speaks volumes, and it speaks louder than tackling whatever is the flavour of the minute.
Yep. Right. And so I'd like to know something, please, about what you've noticed looking at the sort of culture and the appreciation of university spin-outs, which is obviously what your company is. You're studying to be an engineer at RMIT, and you've been looking at this sort of industry of additive manufacturing and businesses emerging from it in recent years. What have you noticed regarding appreciation of university spin-outs in the last, I don't know, however many years you would want to go back?
Yeah, it's really changed, and really changed for the better. So this is one thing I think the Australian tech transfer community or commercialisation community can be really proud of, is the changes that have been made, particularly I'd say in the last 10 years. Although I know the seeds were founded even well before that. In that time, it used to be so incredibly difficult for a researcher, and in some institutes it still is, to get the ability and I guess the blessing of the higher ups to even consider pursuing commercial outcomes. And it's quite a personal risk as well, particularly when it comes to career academics, to take some piece of technology they've been working on and then attempt to make a commercial outcome. It can be, if they're not careful, quite damaging to their career as well in academia. So that entire picture is now beginning to change. So there's some really good headwinds in terms of, or just tailwinds, I should say, that are supporting academics and researchers and the like to actually commercialize this technology, because slowly but surely we're waking up to what's happening around the world, whether that's in like the US and Israel as some of the biggest commercialization hubs, and then across Europe to to a certain extent as well, seeing what you can do when you take commercialization seriously, and the fact that it's not polar opposite to research, which it was viewed as being for quite a long time.
To get some people who are very good at machine learning, and obviously they're quite sought after by all sorts of businesses, and the labour market is tight and has been for some time. Tell me about what you're experiencing with trying to recruit people with the right skills, and particularly those with previous industry experience.
Yeah, it's often hard for a small startup to attract some of those positions and some of that talent that is required, but I think there's definitely been a shift towards startups in the last few years, which is really positive and really encouraging to see, as more and more people are willing to take that risk and go and work for a small company. It's still quite difficult coming off the back of COVID to get some of those positions. So we're definitely hiring at the moment. So if anyone that is listening is looking for a role with some cutting-edge machine learning techniques in additive manufacturing, definitely reach out to me. That aside, I think we're starting to see the back of the COVID-related problems slowly dissipating, which is really exciting. And the other thing too is obviously that some of these large tech companies that have been around that were hiring very large numbers of particularly software developers are now starting to release some of the extra people that they hired and they didn't really need. And so we're starting to see some more talent free up on the markets, which is good for small players and good for innovation as a whole. Even though there are potentially some headwinds leading into next year, quite optimistic about being able to get talent and retain talent and grow businesses in this environment.
Well, onto tailwinds and optimism. Tell me about some of your international customers, some of the people you're able to work with and who have liked your technology enough to become a partner to you. You've only really mentioned Volkswagen publicly. Are there any other international customers who you're able to speak about?
Yeah, so we're working with quite a range across quite a few automotive clients of ours and in aerospace as well in particular, plus a few niche manufacturers around the world and back here in Australia as well. But unfortunately, I'm not able to mention their names publicly at this time. Yeah, I wish I could, but stay tuned and probably have more to say on that in the time to come.
Okay, well, I'll keep an eye out for that. You've been, as I mentioned earlier, engineer interested in and working with additive manufacturing involving metal for quite some time. I'd like to know your view on some of the real important technological improvements that have been made since you started getting interested, and where do you think the next set of innovations will come from?
Yeah, that's a great question. Metal additive manufacturing has definitely gone through a few different peaks and waves of both technology and interest and applications. We've seen it obviously on a very strong upward trajectory for a number of years, and the market reports are definitely painting a very promising future for metal additive manufacturing as a whole. I think some of the big changes that we're seeing at the moment in terms of the productivity are really pushing the boundaries of what was possible a few years ago. So now in the last 6 months or so, we've seen some very, very large machines come online producing components using laser powder bed of several meters in size, which is unheard of before. And in the other wire additive and cold spray technologies as well, we're seeing some very large and very high productivity machines come on market, which is by itself fantastic to see. But I think the next thing that is still lacking in that space is probably the economic side of it, and then the quality side of it as well. And obviously I've got my own bias when it comes to the quality. But on the cost side in particular, we're still seeing very, very large CapEx required to get into this industry. And so some companies are starting to make headway in that space, reducing the capital requirements and increasing the productivity, meaning that the costs of parts are coming down. But yeah, then it's also about balancing that with the quality component and how well you can make parts. So there's some interesting developments in that space, but I guess it's more about continuing to evolve and slowly but surely grow the technology maturity.
Right, and I'd like to get your point of view, please. Obviously, you're dealing with quality of metal parts made by laser bed powder fusion. How many broken or, failed parts do people generally see when they're creating a new batch of whatever? Just tell me about the situation, because, most people could not afford, don't use, have no experience with expensive machines of that kind, and they think, oh, well, this is an interesting thing for my business. I might buy one and end up finding out that it might not make sense because nothing works and it's difficult and it's expensive and everything else. Tell me about the situation with failed parts, please.
So this is one of those things that's highly variable. So you can go into very experienced machine shops and their failure rates can be relatively low, sort of on par with what you would expect from a CNC production facility. When I say very low, potentially in the single-digit percentages in terms of part failures and rejects based on failed outcomes. But then if you can walk into some other shops, you can see a very different outcome. You see failure rates up to 60 or 70%, more than 1 in 2 parts failed, and you see huge bins of scrapped and failed parts. And the difference between those two things is probably twofold. One, what they're trying to build and what they're trying to achieve. And secondly, the experience of the operator. Mm-hmm. In additive manufacturing, the experience factor is possibly the largest determining factor of success. And being able to get talent and people that actually have done it before and know all of the trappings of additive manufacturing, part design, how to run the equipment is really pivotal in creating high and quality production facilities. So if you were looking at getting into additive manufacturing, particularly metal additive for the first time, I cannot stress the importance enough of speaking to industry experts and people that have been there and done it before, because you could spend a lot of time and money on repeating those mistakes, or you could engage with someone and hire people that have done it before. Yeah, if that was me, I know which one I would be going with.
And so another sort of stock question for this series is, why does Australia need a strong manufacturing ecosystem? Based on what you've seen so far in your fairly young career and some of the work you've been involved in and people you've spoken to, what's your answer to that question?
Yeah, Brent, the question of manufacturing in Australia is an interesting one. In my relatively short career still, I've seen the complete retraction of the automotive manufacturing sector. And when I graduated, that was basically unfolding at that time. Seeing that as a backdrop and coming into the manufacturing ecosystem, you would think young engineers such as myself are a little bit naive to go into manufacturing with that as a backdrop. But I think the thing that's probably most interesting here is that it is a really global manufacturing sector regardless. So in Australia, we have some incredible talent. We have some incredible ideas. We have people that are making and are conceiving of some world-leading products. And some of those make sense to manufacture here and some of them don't. So creating an ecosystem and maintaining an ecosystem across different manufacturing modalities has been a really important enabler for those inventions to get off the ground. And so it'd be great to see more of this. However, it's one of those things that there is access to this manufacturing capability around the world, and we do live in a globalized society. So yeah, it's an interesting question, and it's not necessarily clear that we should be making lots of low-value products ourselves, given our wage structure and given our relative geographic isolation. So having some of those key pieces is really important and something that I really like to see. However, it's not important necessarily that we make absolutely everything ourselves in Australia.
I would agree. The Kmart knickers are a job for someone else. I mean, if we could produce them, great, but it just kind of doesn't make sense when you're not adding very much value to something and having to pay people who command first world wages.
Yeah, that's right. Well, the other factor too to remember particularly is the environmental impact of, take that example of the low-value Kmart products. It doesn't make sense necessarily to ship some of those very large, bulky things around the world, and the carbon footprint of that shipping is going to become, it is already and will become more and more important. So there is a case for making some of those low-value, bulky products But it's difficult to justify when there are others that do it better than us and can always do it better than us based on their scale of their economies. So not an easy question.
Yeah, there are a lot of parts to it, and I don't have a coherent answer and wouldn't even really attempt it. I prefer to ask other people, which is what I'm doing here. That's pretty much everything I wanted to ask. You've been generous with your time, and I would like to give you the floor for a moment. If you have anything to plug, you're welcome to do so now.
I think the only thing that would be great to say is that we'll be at Avalon Air Show coming up early next year, and so look forward to seeing a range of the Australian manufacturing and defence community at Avalon next year.
Fantastic. Well, I will see you there, and I'll probably see many in the audience, and it'll be a good time, I'm sure. Anyway, Marten, it's been fantastic to talk to you. Thanks for your time, and congratulations again on the round.
Thanks very much, Brent. Great to speak.